Αγαπητοί συνάδελφοι, καλησπέρα σας. Σας καλωσορίζω στην τρίτη και τελευταία ημέρα του συνεδρίου. Σε μια ημέρα σταθμό, καθώς θα παρουσιαστούν τόσο ομιλίες πολύ σημαντικών προσωπικότητων, όσο και τα αριστεία της ΕΕΦΑΜ. Ας ξεκινήσουμε όμως με την παρουσίαση των Keynote, όπου όλοι ανυπομονούμε να ακούσουμε. Η εμπειρία των τριών αυτών ανθρώπων είναι πάρα πολύ σημαντική και ευελπιστούμε ότι θα αποτελέσουν έμπνευση για όλους μας, τόσο στην επαγγελματική όσο και στην προσωπική μας ζωή. Επιτρέψτε μου τώρα να μιλήσω στα αγγλικά, καθώς ο πρώτος μας καλεσμένος είναι ο Λούκας. So, hello, Lucas, can you hear us?
I can.
Hello.
Hello.
So, Lucas Glass runs the IQVIA Analytics Center of Excellence with a team of over 200 scientists that research and develops machine learning and data science solutions within the research and development space. He has launched over a dozen of machine learning offerings with R&D, such as site recommender system, trial matching solutions, algorithms, you know, all these difficult words that one cannot spell them. Today he's going to narrate us due to the explainability in artificial intelligence in the context of R&D. Our industry, as we all know, has begun discussing the concept of explainability in artificial intelligence. So we wonder, can a user explain how the algorithm came to its conclusion? Often this is seen as something very good, but in fact, as Lucas will tell us, it has a dark side. Rather than improving the clinical and business outcomes, explainability allows people to justify their preconceived biases. So, Lucas, we are all here and listening to you, to this very important presentation. Thank you very much.
Yeah, no, thank you so much. So, can you see my screen now?
No, just a minute, please.
Oh.
Okay, so it's all set.
All right, great. So, thank you so much. This is a fun topic to talk about. It can be a pretty controversial topic in general, because sort of universally people think, oh, you need to be able to explain the science, explain the algorithms to be able to trust them. But what we'll talk a little bit today about is that trust is not achieved through explainability. Trust is something that, I mean, we're all very familiar with it, and gaining trust inside of machine learning is no different than the process of gaining trust in any other setting. I'd like to start with a couple questions. I won't really be able to see hands going up, but who here thinks machine learning needs to be interpretable or explainable? I kind of gave the answer away, or at least in my opinion, away in the preamble to this. But I think it's important for us to think about this, and going into it, do you expect machine learning to be interpretable or explainable as you go forward, or as you think about utilizing it in your organization or in the healthcare setting? And then one other question, which is somewhat different, is, and I like to put this in context, is who here has used AI to help them make a decision today? And being that it's after 5 o'clock in Greece right now, I think it's safe to say everyone here has used some sort of black box algorithm to help them make a decision. The Google search engines are black box algorithms. They don't explain themselves. We don't know how they work. In fact, it's quite a secret exactly how the Google algorithm works. So, but do we trust it? Yeah. I mean, I trust it on a pretty regular basis, and I think everyone else does. So there's this concept of, oh, well, AI has to be explainable, but we don't set that expectation outside of our professional setting, or outside of any setting where we're really understand what we're going after. And there's two things that I like to bring up when we're trying to talk about AI and success. So it's successful when it enhances the user experience of a technology. And I'll talk a little bit about that more. Why are you using the interpretable AI? And I should say, why is explainable AI successful? It's when you're trying to understand for a very specific sort of application function as to why you're creating explainability, I think there is definitely good use for it. But this is the second bullet point I think is really, really critical to our conversation today, that there's got to be a process for the users to gain trust. And process, I have that underlined, because we are, as an industry, very, very, we can relate to the concept of needing a process to gain trust. Medicine, right? Medicine is such an evidence-based, process-oriented thing to gain trust. I think very few industries have that process of trust so ironed out as the life sciences industry. And that same kind of process, maybe a different process, but the same thought, the same concept of creating some sort of process to gain that trust is really, really critical as you're using machine learning, whether it's, getting something to be adopted by physicians, or whether it's getting something to be adopted inside of your organization for things like site selection. The people selecting the sites need a process to gain trust. So it's not about, if I make the algorithm explainable, they'll trust it. No, they need to see evidence of it working over time. These controlled clinical trials that we do in medicine, is there some sort of analogy or analog that we can do in other settings to gain trust in these things? And this is stuff that we do and we monitor very closely inside of our stuff. So I talk about this when explainability helps achieve that UX goal and helps achieve helps develop that process, it's good. But demanding explainability for the sake of trust is an unfair expectation of AI, and it can potentially be dangerous. This is a great paper that was written by a few folks, I believe at Microsoft. We've got it cited down below. They did some tests, and I love this concept of humans trusting AI and when they trust it. There's a good story I'll tell in a minute. But so when algorithms are explainable, people do not increase their tendency to follow a model's predictions when it's beneficial to do so. Models with more transparency, and I don't like transparency because explainability, I think transparency is different than explainability, and I should probably change that word, but that's a quote from the paper. But transparency is now used inside the FDA to be more like, we publish the results, we show the data that was used, we show the algorithm, we make it we don't make this a secret on how it works. Not that it has to be fully explainable, like real time, the doctor needs to know why is this thing recommending this for this patient, but the process needs to be transparent. How did the thing become transparent? But inside of this context, this quote right here, transparency means explainability. Models with more explainability hampered people's ability to detect when model makes serious mistakes and to correct for that mistake. And models that are more explainable, can make people feel like the choice is good and therefore don't do a more aggressive audit. So it actually has some of these counterintuitive things. We think, make an algorithm explainable and it will improve the outcomes. The doctor will make better decisions. But actually, the evidence suggests the opposite. So why do we ask? Why do we have these expectations of interpretability? Well, because logically, it seems like interpretability should be a beneficial thing. But we're all evidence-based. Our entire industry is evidence-based, and so we should expect that same sort of evidence base outside of, in AI and interpretability of AI. Let's make sure that interpretability actually provides or increases the clinical outcomes for our patients. Before I get into this Shapley additive explanations, which is one of the main explainable tools that machine learning uses now, I want to tell a little story about trust and AI, which is just shows how complex this space is. There was a test run. I've forgotten. It might have been a Georgia Tech. I've forgotten exactly where it was run. But what they did was they created a robot, and the robot was put in front of 30 individuals, and the robot on each individual was trying to direct them out of fire, right? But they took them through hallways to direct them outside of like a fire escape, and there was very clearly labeled signs: fire escape this way, fire escape this way, just like you would in any sort of traditional public building. But the robot took people and was signaling and saying, "Hey, please follow me. I'm taking you to I'm taking you to safety." And 30 out of 30 people followed the robot to a secluded room without any exits that would have sort of surely been a death trap for them. So even though there were signs posted all over the place saying exit this way, they ended up trusting this robot that was sort of signaling them in a certain direction. And so I love that story because, we all think that we're very smart and we can overcome any sort of incorrect information thrown at us. But while we are a very intelligent industry, we're human beings first, and we have to really think through the psychology of why we make the decisions we make, and explainability has a big impact on that. All right, so I'm going to get a little technical here. This is Shapley additive explanation. So why do I transition into this? Shapley additive explanations is a way of taking black box algorithms and actually showing how the system works. So now that I've hopefully convinced you that there are examples where explainability is useful, but using it for the sake of just demanding it that's going to help you gain trust in the algorithms or improve clinical outcomes is not wise, right? But now I'll show you ways that you actually can use it. So this tool helps you open up the black box. SHAP, this Shapley additive explanations, any clever AI algorithm these days uses some sort of abbreviation. It's a unified approach to explain the output of any machine learning model. It connects game theory with local explanations, uniting several previous methods and representing the only possible consistent and locally accurate additive feature attribution method based on expectations. Now, that statement is no longer true because there's a lot of research being done that sort of further enhances SHAP, because SHAP was published at NIPS, which is the top AI conference, in 2017. And it's been 5 years since then. But it's still sort of the foundation. It's like the hallmark of explainable toolkit. So this is SHAP. And this is my SHAP explained slide. So I've got 4 digits along the left side. And then along the right, you can see there's 10 columns, and it's going to explain, so what was it about the pixels, the individual data points that went into this black box algorithm that had the algorithm recommend it for this specific thing? So this first column is why did it or did it not recommend it as a 0? The second column, a 1, the third column, 2, so on and so forth, all the way to the last column, which is why did it or did it not recommend it as a 9? And you can see the 2, it's showing, oh, these are the pixels that were really important to us and why we called it a 2. And you can see there's some things in there that say, oh, well, some of the areas that are really critical to having a 2 or being a 2 are highlighted in bright red, right? And so it's saying these were the critical data points that informed the algorithm to make this suggestion. And if you look, I don't know if you can see it very, very well, the first column, there's a little bit of shadows of blue where it says, well, it's missing these things on the outside, which is why we're not calling it a 0 over in this first column. And then I'll show you down at the bottom, the 4, right? So they called it a 4. And the critical things as to why they called it a 4 was that it didn't have this little bar at the top, right? And saying that missing bar is really, really, really critical to being a 4. And if you look at the last column, which is 9, it's saying, oh, we didn't call it a 9 because it's missing that top bar. To be called a 9, that's a really critical thing, that it has the little filled in pixels at the top. So what's this doing? This is literally taking a black box algorithm and making it explainable. So it's not about, can we make algorithms explainable? We can. Any algorithm can be explainable. Don't let anybody tell you otherwise. They can be explainable. The question is, should we, not can we? All right, and now I'm going to start talking about some actual applications of it, which I think are pretty interesting. So EMR queries. This is an area where machine learning has come up quite a bit, and trying to predict who's going to get certain diseases, who's underdiagnosed with certain diseases. And what we found was actually operationalizing these things was very difficult. So to be able to deploy a machine learning algorithm at bedside, real time, or even just in the EMR system, there is a lot of regulation, a lot of privacy issues that you got to get through that make that very challenging. So what we did in our application was, well, can we just use SHAP to help understand how the algorithms are finding the patients, as opposed to actually using the algorithm on individual patients' data? Can we just figure out what this algorithm is doing using SHAP? And so it did. It came up with a couple key things here, and it said, oh, well, SHAP said, a high BMI of greater than 35, age greater than 40, and 2 other things, fatty liver and hyperlipidemia. Now, maybe it's not super, there's not some crazy revelation here from this, but this was different than the algorithm that they were presently using to try to find things. The simple, 3-step, 3-rule thing that the AI combined with explainable SHAP found were actually performing much better than the rules for trying to identify patients with potential SHAP that had come from the medical literature. And our results, we were providing substantial reduction in identified patients requiring NASH screening. We were 22% of the eligible patients confirmed to have NASH, and greater than 55% FibroScan with greater than 7.5. I don't even know what that means, to be frank, but we worked on this with the physicians in the space, and apparently that was important. So you can see, I didn't use explainability just because I wanted the doctors who used the algorithm live to know how it was working. I used explainability for a very specific purpose, and that was, what are the insights from the algorithm that I can use for other purposes, for actually trying to use the insights themselves, as opposed to using the explainability to help me gain trust in the algorithm. All right, chemoinformatics. This is another one that my organization does quite a bit of. So we might want to predict which drugs are going to have interactions. Sometimes we also want to know which drugs are going to combine or interact with certain proteins, right? And what's very interesting about this is, well, one, obviously getting good predictions about which drugs are going to interact is really powerful for repurposing, or, if you're trying to do drugs and proteins, and understanding the chemical interactions. But then there's this really useful application of explainability here, and that is, is there some insight that this is finding that's saying that, oh, these specific things are interacting that maybe our chemists didn't find, or that maybe we can gain some insights into how this is showing these drugs interact, or these molecules interact, that goes outside of the current landscape of knowledge, and being able to mine a lot of this data to understand and gain insights. And so that insights, again, that's the second time I used that term, insights. we now have good insights as to why drugs interact and molecules interact and drugs and proteins interact with one another. And that's a very good example of where explainability is helpful, gaining insights. Site identification. We have so much data at IQVIA. It started to overwhelm the doctors as we started to put information in front of them on which sites you might want to select for a clinical trial. It just gets like, I like to say that the back of the sports card is only so big. There's only so many stats that the brain can look at, right? But a computer is insatiable. They have unlimited appetite for data. Basically, as much compute as you can throw at them, they'll use. And so when we started dumping all this data at the humans, their brains started shutting off and they stopped getting the value from it. But what you can do is, and this is a tool that we've got, you can actually create some way that you can show pulling all of this together and saying, oh, well, think about those red dot, green dot, or red dot, blue dots. Like, what data points was the algorithm finding that could help you to recommend these sites? And so it's not just a recommender system, it's a way to mine the data for the important information. When there's just too much information for the human brain to look at, it can highlight what's the most important for you to look at. So there's a very good reason for the explainability here, to reduce the amount of information that the human needs to process inside their brain. Because the algorithms can outperform humans. Humans can sometimes outperform algorithms, but very rarely can a human working hand in hand with an algorithm get beat by either one of the algorithm or human alone. All right, and you can see these are some actual results. This is not the algorithm results. This is the actual application in production of our system, that we have quite a huge improvement in these tier 1 sites are the ones that we recommend. And unfortunately, there's always sites that our algorithms don't recommend that get in, which helps me create these sort of real-time results because I can do benchmarking and comparison. But I wish in operations we would only ever select the ones we recommend, but it's just not the reality. Sometimes there's not enough of them. Sometimes our sponsors demand certain physicians involved in the study, but there's all sorts of reasons. All right, another great example, centralized monitoring. So this is that same sort of reduction in data and information that there's so much for the humans to look at, right? But now if we can create algorithms that can actually predict which doctors or which sites or which data points are potential challenges, potential fraud, or potential, some sort of outliers or any sort of duplicate detection, right? The algorithms are good at finding that, but they're also good then at that same thing using explanations. Well, what is it that the human should look at? There's just so much data for them to look at. Can this algorithm say, hey, we found these ones as high risks, but we also found this backup data as the real important things to look at for that monitor to understand what's the real important stuff. So again, you see, so this is a second example of when explainability is real useful. The reduction of the amount of information that the human needs to look at and review when there's just so much big data. So we had first was this gaining insights. The second is this reduction in data that the human needs to look at. I also have this other thing. Document management is a real big area for AI. And so we do translations. We have AI-based translations and AI-based translation service at IQVIA. And the way that it works is the algorithm takes the documents, structures it or unstructures or structures it however it's supposed to be done, translates it, and then goes in front of a reviewer. And then the reviewer, the translator, actually, instead of having to translate from scratch, they edit what the AI did. And so they're just going through, and it takes substantially less time, and it increases the quality of those translations. But does the algorithm really need to be explainable here? I'm not sure it does. And for me, maybe there is a specific reason, but I don't see it right away as to why we would demand explainability on this algorithm. Because if there's a human coming in after the fact and saying, "Oh, here's the AI translation, I'm going to edit it," I think that's sufficient, and they can just go through and understand and see these things. They don't need to understand why the algorithm said it's this word and not this word. And I think this patient recruitment is, I think, the most challenging one, because this gets into treatment decisions and diagnosis decisions. And I think this is my last slide here. So I don't have a good answer on this one, what my perspective is in terms of explainability, because what we're showing here, Deep Enroll, this is my algorithm for matching a patient to a study. I tell a story a lot that my grandfather died of progressive non-Hodgkin's lymphoma in the mid-90s, and progressive non-Hodgkin's lymphoma was basically cured if you were CD20 positive in the late 90s by rituximab. And so that means there was literally a clinical trial out there that could have potentially saved his life. I don't know if he was CD20 positive or not, so maybe not, but just the fact that there's a chance. And there was never a way for this, integration of clinical research as a care option inside of, his physician's practice. To me, makes it, I'm very passionate about how to embed this into the clinical setting, into the more traditional clinical setting. And so I think, well, if I have an algorithm that says, hey, this patient would benefit from this study, is explainability important? Why I think this patient would benefit from there? And I'm not coming to come up with some sort of answer today. I'm just more putting this out there as a potential thought question. Well, should this be explainable? We are evaluating and thinking about this and trying to make sure that we've got a good mechanism, or the best mechanism, for ensuring that we do effectively embed clinical research as a care option. But I haven't landed on a very good use of explainability in this, but I'm not ruling it out. All right, and I'll leave you on this screen. This is the robot that a bunch of people trusted blindly, even though there were very, very clear, well-labeled emergency exits. They followed the robot. With these wands saying, "Follow me this way, follow me this way, this is the way out." And so when and why we trust AI is a very complicated question. And what we do to try to gain that trust in AI has got to be a process, and a well-deserved process, similar to the way that we gain trust in medicines. It's not about explainability, it's about a process. And with that, I will stop. So thank you very much.
So thank you very much, Lucas. Really, you made difficult meanings here in Greece and in this convention to be seen simpler to all of us. So I really have a small question for you. So until now, I don't know, can you hear us?
I can.
Okay, yes. So do you believe that AI right now, but also machine learning, has started to do things that people did until now? So what do you believe about this trend? Will AI make people not think so much and trust the robot?
Yeah. I think it's got to be something that we be very careful about, right? So the things like YouTube and Facebook and them have really found ways to turn off the brain and get you to mindlessly follow their algorithms. And, and I think that's something that we really do have to be careful of, because, I start to study things as to how to get people to trust and adopt AI more. And one of the best examples is put a default, right? Meaning don't go in and say, oh, hey, here are the things that I think you should choose, and here's why I think you should choose them. It's, I chose this one. Change, if you want to change it, go ahead, right? And that's, you think about, that's how YouTube and them work. It says, oh, we're going to go ahead, stop me. And that's a really good way to drive adoption, but it creates some challenge because it does turn off the thinking part of your brain. And you end up going straight into the, oh yeah, I'm going to trust it, I'm going to use it. And so creating those defaults is, there is some risk there. And I do use defaults in certain circumstances where it says, well, this action is going to happen, like picking a site for a clinical trial, because that's creating that default isn't a terrible thing. Worst thing that happens, the site says, no, I'm not appropriate for this study. But, if I were to create that sort of YouTube-like default for a medicine saying, hey, doc, stop me. I'm going to prescribe this medicine unless you stop me. I think that might be a risk that we shouldn't take.
And last questions. What does the doctors say about it? Do they really ask for the explainability in the medicines and the algorithms?
Some do, some don't. I think when I have this conversation with doctors, the sort of initial reaction is, yes, I want to understand how the algorithm's working. But then when I say, well, why? It's, well, because I don't trust it. It's like, okay, but maybe we should have a different way. Maybe I should create some sort of, controlled clinical trials or some sort of real world studies to show you that in practice, this is working well. Or maybe I should publish the results of this algorithm in some way and continue to show you the performance of this algorithm in the real world study, some sort of registry. There's a lot of talk about creating some sort of more real world registry type things of AI algorithms to gain that trust. And I think that's the way to do it. Think of it much more like a medicine that you gain trust in, and explainability isn't going to get you there.
Okay, so thank you very much, Lucas. It was a really honor for us to be here. And of course, thank also Nikos, but he's not here. I mean, Nikos Kostas that made the relations between us. So thank you very much for your participation in this Congress.
Yeah, my pleasure. Thank you for having me.
Thank you very much.